Hello students, today we're going to learn section 9.4 symmetry. Now symmetry is an isometry that maps the figure onto itself. We will have reflection symmetry, sometimes it's called line symmetry. It's one half of the figure is a mirror image of its other half. Rotational symmetry is its own image for some rotation of 180 degrees or less. Point symmetry has exactly 180 degree rotational symmetry. In example 1, they want us to draw all lines of symmetry. So for example, this is a regular hexagon. So there are more than one line of symmetry here. We have this line here. So if we were to fold this in half, the line of symmetry which runs along this line here, when we're to fold it in half, the first half maps onto the second half. If we looked at this line of symmetry here, horizontal, okay, so what that's going to do is, here is our regular hexagon. We fold it, and now the first half folds onto the second half. So that's what reflection symmetry is. It's one half of the figure is a mirror image of its other half. And the other lines of symmetry, as you can see, is this here. So from this vertex to this vertex, if you can imagine again, here's the cut. When we fold it, it maps onto itself. Okay. So those are the different types of symmetry that we have. And there are 1, 2, 3, 4, 5, 6, about 6 lines of symmetry. So again, we could take a look at this line of symmetry here. So when you fold it in half, it maps onto the other half. Alright, so that's for a regular hexagon. In a rectangle, there's only going to be 2 lines of symmetry. A vertical line of symmetry and a horizontal line of symmetry. So again, we call this a reflection symmetry because it reflects. It has the exact same shape. So if we were to fold it along the vertical line of symmetry, the first half maps onto the second half. If we were to fold moving along the horizontal line, again, that's going to map onto itself. Now, the reason why we can't have a diagonal symmetry, a diagonal line, is look at when we fold it. It's not mapping onto itself. It overlaps. So that's why these are the only 2 reflection symmetries. Alright, example 2. It says determine which types of symmetry each image has. So let's take a look at this star here. First, I know the star. If I rotate this star counterclockwise, and I rotate it 72 degrees, if you notice, the shape is going to map onto itself. It's exactly the same image. So this is rotational. And the rotation is 72 degrees. The reason why I know it's 72 degrees is if I create a circle, divide by 1, 2, 3, 4, 5 angles, and this is a star, and it's a perfect star, each angle is 72 degrees here. So that's 72, that's 72, that's 72. So again, every time you rotate 72 degrees, you get the same shape. Now, if you only, let's say, rotate 36 degrees, the star does not map onto the original star. But if you rotate 72 degrees, it's going to map onto itself. All right. I also noticed that we could have a reflection symmetry. If we have a line and we drew it right down the middle, right here, and we folded it, it's going to map onto the other half perfectly. Okay? So this also has a reflection symmetry, but there's only one. So this is also a reflection symmetry. So that's a reflection symmetry. All right, next shape. This is a regular hexagon, just like this. We know that this is a reflection symmetry already because of what we just did up here. So this is a reflection symmetry. So that's a reflection symmetry. And let's see if it's rotational. So this is a regular hexagon. If I rotate it, it maps onto itself again. Rotate it another time, it maps onto itself again. So this is also a rotational symmetry. And the rotation I used here was a 60-degree rotation. So every time we move 60 degrees, it mapped onto itself. Now, and again, it's rotational because it has to be 180 degrees or less according to our definition above. All right, now if I went 30 degrees, it's not going to map onto itself, but 60 degrees, it does. All right, so let's take a look at this next shape. So these are glasses. So let's check if it has rotational. Let's see. This is 90 degrees. That's 180. Well, we don't have rotational because rotational is 180 degrees or less. So we start here originally at 0. We rotate it 90 degrees. It doesn't map onto the original image. We do 180 almost, but it's not fully there. But if I did 360, a 360 degree rotation, yes, but rotational symmetry is equals or less than 180. So the only type of symmetry that would be here would be a reflection symmetry. Because if we folded this in half, we map onto itself. Okay. So again, if we fold this in half, it maps onto itself. So this is only a reflection. All right, that's it for today.